The M1074 Joint Assault Bridge System, JABS, is an American armored military engineering vehicle based on the Abrams M1A1 main battle tank. The M1074 was designed by Leonardo DRS Technologies to provide deployable bridge capability for units engaged in military operations. The bridge is an Armored Vehicle Launched Bridge, AVLB, Military Load Class 95 Scissor Bridge, MLC-95. After the M1074 has deployed the bridge, assault force vehicles can cross over the bridge. The M1074 can cross over, pick up the bridge on the far bank, and continue along in support of assault forces. The JABS was conceived as a compromise between the M104 Wolverine, that was deemed too expensive to operate, and the aging M60 patent-based M60 AVLB, which could not adequately support the Abrams and Bradley vehicles. The vehicle provides the Army Mobility Augmentation Company supporting armored brigade combat teams with a survivable, deployable, and sustainable heavy assault bridging capability. Prototype development began in May 2012, when the U.S. Army Contracting Command awarded General Dynamics Land Systems and Leonardo DRS a $26 million contract to build two Joint Assault Bridge System, JABS, prototypes. The contract supported the engineering and manufacturing development phase, with the GDLS prototype being built in Sterling Heights, Michigan, and the Leonardo prototype built in West Plains, Missouri. The Army wanted the winner of the contract to include Anniston Army Depot's organic industrial base experience in the JABS production. The XM1074 JABS prototypes were ready in 2014. They were delivered to Anniston Army Depot, ANAD, where they underwent testing and evaluation through 2016, with the Leonardo prototype being accepted as the M1074 in August. Leonardo DRS has a public-private partnership with Anniston Army Depot in Alabama to manage the M1 chassis assembly, and worked with Israeli Military Industries, IMI, on the design and engineering of the bridge system, according to a DRS statement. On August 23, 2016, DRS Technologies Incorporated announced that the U.S. Army had awarded it an indefinite quantity contract worth up to $400 million to build the new Joint Assault Bridge System, JABS. The Army has placed an initial order for 168 vehicles, and the Marines for 29. The JABS completed its low-rate production phase from 2016 to 2018 with a total of 51 vehicles. ANAD produced 10 in fiscal year 2016, 14 in 2017 and an additional 27 in 2018. These first JABS underwent exploitation and fire survivability testing at the Aberdeen Test Center. These tests finalized the current configuration for full-rate production, and evaluated some configuration changes in the design for crew protection. United States Army Operational Test Command, Fort Hood, began conducting operational testing in April 2019, with the 40th Brigade Engineer Battalion, 2nd Armored Brigade Combat Team, 1st Armored Division. Full-rate production is scheduled to start in 2019, and expected to be completed by May 2024. The M1074 JABS will replace the M60 AVLB and M104 Wolverine on a one-for-one basis in the United States Army, Army National Guard and Marine Corps. The Australian Army is planning to purchase 18 M1074s, with the US government granting approval for this in April 2021. The M1074 Joint Assault Bridge System, JABS, is based on the hull of the M1A1 version of the M1 Abrams main battle tank, using the suspension system from the M1A2, and upgraded with the Total Integrated Engine Revitalization, Tiger. This is projected to lower maintenance costs as well as increased availability and unit readiness with commonality of parts with the Abrams chassis. The unit has a new hydraulic bridge launcher system as well as embedded diagnostics. Survivability is enhanced with components of the Tank Urban Survivability Kit, TUSK, including Abrams Reactive Armor Tile, ARAT1, Rearview Sensor System, RVSS, and Tank Infantry Phone, TIP. Additionally, it can employ the Auto Flood Driver's Seat and Abrams Lightweight Underbody Kit for situational use. The vehicle itself is unarmed. However, the crew members are typically armed with assault rifles, M16 or M4, pistols, flares, and/or colored smoke grenades. The Bridge Launcher Mechanism, BLM, was designed by Israeli Military Industries in conjunction with Leonardo DRS. The bridging controls are a basic push-button system, similar to the M104 Wolverine, while the computer assembles the bridge and deploys it. The bridge extends its span vertically instead of horizontally as the M104 Wolverine. It can deploy an MLC-95 bridge with a gap crossing of 18.3 meters in approximately 3 minutes. An Armored Vehicle Launched Bridge, AVLB, is a combat support vehicle, sometimes regarded as a subtype of military engineering vehicle, designed to assist militaries in rapidly deploying tanks and other armored fighting vehicles across gap-type obstacles, such as, and primarily, rivers. The AVLB is usually a tracked vehicle converted from a tank chassis to carry a folding metal bridge instead of weapons. The AVLB's job is to allow armored or infantry units to cross craters, anti-tank ditches, blown bridges, railroad cuts, canals, rivers and ravines, when a river too deep for vehicles to wade through is reached, and no bridge is conveniently located or sufficiently sturdy, a substantial concern when moving 60-ton tanks. The bridge layer unfolds and launches its cargo, providing a ready-made bridge across the obstacle in only minutes. Once the span has been put in place, the AVLB vehicle detaches from the bridge and moves aside to allow traffic to pass. Once all of the vehicles have crossed, it crosses the bridge itself and reattaches to the bridge on the other side. It then retracts the span ready to move off again. A similar procedure can be employed to allow crossings of small chasms or similar obstructions. AVLBs can carry bridges of 60 feet, 19 meters, or greater in length. By using a tank chassis, the bridge layer is able to cover the same terrain as main battle tanks, and the provision of armor allows them to operate even in the face of enemy fire. However, this is not a universal attribute. Some exceptionally sturdy 6x6 or 8x8 truck chassis have lent themselves to bridge layer applications. The roots of the modern AVLB can be found in World War I, at the dawn of tank warfare. Having developed tanks, the United Kingdom and France were confronted with the problem of mounting tank advances in the face of the trenches that dominated the battlefields. Early engagements, such as at Cambrai, demonstrated the tank's utility, but also highlighted its vulnerability to battlefield geography. Many early tanks found themselves ignominiously stuck in the trenches, having insufficiently long tracks to cross them, as at right. To counter this disadvantage, tanks, especially the common British heavy tanks, began to go into battle with fascines, sometimes as simple as a bundle of heavy sticks, carried on top. By dropping these into the trenches, they were able to create a wedge over which the tank could drive. Later, some tanks began to carry rails on their decks, the first AVLBs. By 1919, the British Army had, at its training center in Christchurch, a Mark V tank with lifting gear, able to carry and place a bridge or carry out mine clearing and demolition. It was in the World War II era that the importance of armored bridge layers, as well as combat engineering vehicles and armored recovery vehicles, became fully clear. With the advent of blitzkrieg warfare, hull divisions had to advance along with tanks, which were suddenly far outpacing the speed of infantry soldiers. Besides leading to the advent of self-propelled artillery assault guns, mobile anti-aircraft and armored personnel carriers cars, it became clear that functions like vehicle repair, mine clearing, and the like, would have to be carried out by armored vehicles, advancing along with tanks. Moreover, these forces would have to be able to cross all forms of terrain without losing speed, and without having to concentrate their thrusts over certain bridges, and the rising weight of armored vehicles meant that fewer and fewer bridges could support these mass crossings. The only feasible solution to the dilemma posed by the mobility of all mechanized armed forces was a dedicated platform that could improvise river and obstacle crossings at short notice, and in otherwise inconvenient locations. Tracked and armored, it was capable of operating right alongside combat units, crossing rough terrain, and advancing in the face of light fire. To maximize on common parts and ease maintenance complications, they were usually based on existing tank chassis. One of the earliest series-produced examples is the Birkenlager IV, a German AVLB based on the Panzer IV, which entered service with the Wehrmacht in 1940. 20 were built, but problems of excessive weight limited the vehicle's effectiveness, and eventually all 20 were converted back to tanks. A new Scissors bridge design was brought out by the British in response to the war, sufficient to support a 24-ton load over 30 feet, 9.1 meters. This was developed for the Covenanter tank. Eventually, it developed into a 30-ton capacity and therefore was carried by a turretless Valentine tank. It was used in Italy, Northwest Europe and Burma.